I became kind of interested in something like this when I was just playing around with a little Arduino microcontroller, and on this Adafruit website they have all kinds of tutorials, one of which was this one here by Tyler Cooper, who used Arduino microcontroller and some parts to build a reverse geocache box, and he used it to propose to his girlfriend. So it's a pretty interesting story. I followed his instructions, Tyler's instructions, fairly closely, but I used some different parts and took some code from here and there. But here, let me walk you through my own installation, or my own build of this project. First, let me show you the parts list. First thing I had was this Arduino Uno microcontroller. It's about $24.95 at adafruit.com. And then I picked up this GPS logger shield from Adafruit as well, and you can see here the GPS antenna right there, and this prototyping area here where you could wire in some different components as you need to. I was initially really afraid to do that because I'm not much of a soldering guru, but I ended up using it. It worked really well. I ordered one of these from Amazon.com. It was a Sane Smart LCD module, and it has a little I2C backpack, I guess they call it, which lets you save some pins on your microcontroller. It's actually very easy to use, and 4 lines is more than I needed for this project, but that was $14.99 for that. And this is a Pololu push button power switch, and what it does is it allows the box, the whole thing, to power down with just the use of one button, without having a big toggle switch or something on the front of it. I found that, I don't remember if it was in Tyler Cooper's tutorial or if that was in a different one, but it was a very useful thing, except if you're going to be using the 9-volt power supply, you should probably have a standard voltage. They have 2 versions of this, the standard voltage and the low voltage, and I initially ordered the low voltage. It's wasn't enough, so that was $6.95 at pololu.com, Pololu.com. This is my battery holder that I used. Looks just like that, except I stripped off that end and just plugged or soldered in the connections directly onto the board. But it's just a 9-volt battery holder, and I needed a 10K resistor, just one of them, as a pull-down resistor, which that took me a while to figure out. You could buy this for like 95 cents for a 20-pack, I think, at sparkfun.com. I just happened to have one here, so I didn't actually have to order that. This is just the button on the front of the box that I use. It's a 16mm panel mount momentary push button. Again, you can get this for 95 cents at adafruit.com. I actually picked one up at Menard's hardware store. I just saw it there and I thought, oh, that's perfect. So, but that's pretty much the same button I have, as you'll see later. I had to use one of these Tower Pro micro servos, which this one is what about $5.95 at adafruit.com. There's these little tactile button switches. You can buy a 10-pack of them for $5.35 on Amazon.com. I needed one of these to program in an input on my board to temporarily open the box so I could actually lock it. I used some of these partly when I was prototyping, and I think I may have, yeah, I used a few of them in the final product. But they are just, let's see, female to male and female to female wires. I used some 22 gauge solid core hookup wire. It's like you can get a roll of that for $2.50 at adafruit.com. And I actually had a few different colors just on hand, so I was using those. Some old speaker wire or something I had laying around that worked really well. As far as the actual box itself, I made use of a box just like this from Hobby Lobby, and it looks like I was able to get it for $8.99. I bought the middle-sized one, which is about 9.5 inches or 9 3/4 inches wide, and so on, and worked really well. And then I got a little wooden dowel for about 60 cents, also at Hobby Lobby, and that I used that as the latch on my box. And I used some other scrap wood that I had just laying around the house here. And then I had some eyelets, those little eyelets right there. That was what I used to guide the latch as it moved. And of course I needed some stain, some polyurethane varnish, some foam paintbrushes, some scraps of sandpaper, you know, just things like that. And well, here I am trying to build it together, put it together. Doing it on a breadboard right there. You can see I've got my power switch connected into the Pololu power switch, and then I have those connected to the power supply here, and then in this picture it actually goes to a USB cable, which I was using to power it. In the final product it's a 9-volt battery. But this allows me to turn the device on and off with just the one button. It's a really slick thing. And you can see the GPS shield on top of the Arduino board. Got my LCD display there. So this is you know, probably 2/3 of the way through the project. It was just one thing after another. Okay, got to get the display working. I got the display working. Okay, got to get the GPS working. Okay, got to get the servo working. And now got to get the power supply working. And then now I got to get them all working together. It was quite a project. It's fun. Here I am continuing to build the box. There I'm assembling the servo. I got my little tape there because it's just temporarily mounted while I adjust it and tweak it so that it'll actually meet up with the lid eyelet, which you can see right there. It does. That was before I put the display in, so I could actually reach in there and open the box still. I didn't want to lock it up too prematurely. There, finishing touches, and here's the final product. There it is. I just happen to have that Tupperware container laying around the house, and it works pretty well so far. Enjoy it. Oh yeah, I did have a back door I put in, as you can see right up here. There's this little 3-wire plug that goes through just the rim of this. I just super glued that in there, and these 3 wires run along here and they intersect, they splice into the servo. So in the event that I accidentally lock the box or the battery goes dead and I need to open it for some reason, I can still do that. But to do it, I need another Arduino board or microcontroller to plug directly into the servo, basically, and then to open the servo to power it, kind of bypassing the existing Arduino board inside. Not the best way to do it, but in the future I would probably sneak in a little USB port right there or something and plug that into the internal Arduino board so that we could program it and power it that way. But this worked well enough. I did have to use it because I accidentally locked it once and had to get in there. Okay, there it is. That's the finished product. And here's the code. You can see I've called it reverse geobox. That's what I called the sketch. And you can see I haven't really touched up the comments and so on. This is based on the engagement box sketch by Kenton Harris from 2012. This program unlocks a box that has reached a certain location. And so that's the whole idea. I had to use some different libraries than Kenton did. I used the EEPROM library to, store in the little EEPROM on the Arduino whether or not it had been solved. If the box is ever at the latitude and longitude that it's supposed to be at, it'll open, and then you have to come back and reset the box with that little push button switch inside the box in order for it to lock again. Let's see here. I set up my serial, software serial, and I use that for the GPS. The GPS chip simply talks through software serial to the Arduino board. I had to use a different pulse width modulation servo because the servo module that is included in Arduino, it had some issues with the servo and some interrupts. Took me a long time to figure that out. This was kind of clever, I thought. I don't know if it was Mark Hart, the guy who originally did the first Geocache box, or if it was Kenton. Yeah, they figured out, even with the curvature of the Earth, how far away we are from a certain spot on the globe. So I converted it to miles, and then actually it changes to feet when you get within a mile. Here's my liquid crystal display with the I2C protocol. Declare a bunch of variables. Here's where I declare the latitude and longitude that the box will open at. So I mean, that's right there. That's all you need to do to change where it will open. Just adjust that, and you can get the coordinates of any place on Google Maps very easily. So that worked pretty well. Right here, I should mention up here, max range to open. How far away from there, latitude and longitude, can we be and still open the box in miles? So 0.05 miles, I think it's like 200 feet or something, it'll open up. So all that's just declaring a bunch of objects and variables. Then we set everything up, set up our pins, set a shutdown time. It'll shut down the box after, what did I say, max time to run, 2 minutes right now is what it's set to. It sets up the servo, sets up the LCD module, sets up the GPS module, sets up the lock button, which when pressed will open the lock for a set time to allow the box to be closed before finally really locking it. I had to figure that was a pain because I got the project almost done, and then I made the obvious observation that in order to program the board, the box had to be open. And once you programmed it to only open 50 miles away from where you currently were located, it would lock. But with the lock in the latched position, you couldn't close the lid. So I had to go back to the drawing board. So that's all the setup. Then down here in the loop, it just basically, I'm not going to go through all of this. If it hasn't been solved yet, it will look for a GPS signal. It'll calculate the distance between where the GPS is currently located and where the destination is, where there is. And if it's within 0.05 miles, it will unlock and say congratulations, and then you get your prize. You can see some information here about interrupts. That was new to me as well, and some supporting functions that I did not write. Those were in there from either Mark Hart or Kenton Harris. So lots of parts from lots of different coders out there. I kind of pieced it together, and I suppose I can put the code out there. So go to learn.adafruit.com for more detailed tutorial on all this. All right, well, here it is, the finished box. Let me see if I can show you how it works. Now, normally what happens when you push the button, if the box has already been solved, you can see it says box is unlocked, and then it turns itself off, which that Pololu switch I mentioned allows that to happen. So box is unlocked. It's been solved. In order to lock it, you have to reprogram it. Now, let's say you want to put your candy bar in there, and you want to close and lock the box. In order to do that, the way it's set up right now anyway, it's not the best. You have to hold down this little switch here, this little push button switch, while you power on the circuit. And when you do that, it will say, it'll start up, and okay, I missed it. I'm gonna try it again here. Okay, you hold down that toggle switch, power it on, and it'll go into unlock mode. It'll say locking in 58, 7, 57, 56 seconds. That gives me time to, while the latch is still in the open position, to close up this Tupperware thing here, and to make sure my prize is in there, make sure I really want to lock it, because once it's locked, it won't open again until you get to the programmed latitude and longitude. So, there, it's ready to lock. Now, I've got 27 seconds. I actually had to do that, I had to add that little push button thing in because I initially built the whole thing, but I didn't have a way, because once I programmed it, it would lock immediately, and then it wouldn't. Then I couldn't close the lid. I had to rewire in another input so I could have it locked. Okay, there we go. Locked. The servo moved to close the latch, and now you can see it's 456 feet away from here. The box will not open unless we get there, and you can push the button and it'll power it off to save battery. After I have it programmed so after 2 minutes it would also turn off. You push the button and it gets a GPS fix, and it's 475 feet away. All right. Well, let's see here. Let's go check it out. Okay, so here we are. Got the box. It says 444.52 feet. If I start walking, it should change. The hardest part about this sort of thing, though, is knowing exactly which direction you're supposed to go. Of course, I know which direction because I programmed in the latitude and longitude. 420. Okay, let's just fast forward here to the... After 2 minutes, it powers down. 270 feet. Oh, there it goes. I heard it. Congratulations, box is unlocked. And there you go. Now that the box has been unlocked. The flag has been set in the EEPROM, and it won't lock again until you hook it up and reprogram the microcontroller. Okay, I realized I didn't show you how it actually goes. And you can see I've got it ready to lock here in just a few seconds. I wanted to show you the servo in action. So yeah, here you go. There's the servo. Now, right there, that's that little micro servo. So whenever you get the GPS sensor right there, it gets within a certain distance of the programmed coordinates, the servo will open the box. Right now it's in the open position. You can see it's retracted. It's like the bolt of the lock is retracted. In a few seconds here, it's gonna lock. There. So it's now in the lock position. So normally the bolt, the eyelet on the lid would be caught now, and it wouldn't be able to open the box. Let me show you what it looks like when the box is actually locked. So I'll just reset it again into unlock mode so you can see the latch opened. I close the box, and now in 50 seconds. Okay, here we go, and it's locked. Okay, now you can see, yeah, it'll shut off there. Now watch, it's hard to open. I mean, I tried to get it as tight as I could with the latch. Now, unfortunately, when I give this box to people, first thing they do is try to really pry it open. If I were to do something different in the future, I would, if I were to build this again, I would put an extra eyelet, three of them instead of two. Two on the bottom, one over here and one over there on the left, and then one in between them from the lid, so that when you pull up on it, it didn't push like a lever on that little plastic servo. It's kind of the weak point. But anyway, it works, and it's a lot of fun. All right. Thanks for watching.